Okay, welcome back everyone. Now we're going to work on system. We've been working on systems of equations. This time we're going to look at the number of solutions, like how many solutions could there be, and that will be covered in U5, the number of solutions to a system of equations. Let's go ahead and get rid of this. Okay, let's get started. Number of solutions. There are three possibilities. The first possibility is that there are none. If these two lines are parallel, they will never cross, meaning they do not share any points. Therefore, there are no solutions if the two lines are parallel. The second possibility is there's one. Two straight lines can only cross one time. They either cross never or they only cross once. They can't cross twice or three times or four times. But then there is the third possibility, which is that there's an infinite number of solutions, not 2, 3, 4, 5, 6, 1, but an infinite number. And that would only be if they were the same line. If they're the same line, they both have all the same points, then they share an infinite number of points. So three possibilities: none, one, or infinite. So let's start with the first one, no solutions. How do you know there's no solutions? That's if they're parallel lines. How do you know if they're parallel lines? What does parallel lines mean? It does not mean railroad tracks that go on for never and never touch. That's kind of a simple explanation, but the mathematical explanation is that they have the same slope. They have the same slope. Where do you find the same slope? You find it on the m in the y equals mx plus b. Once you get into y equals mx plus b form, then look for the m. If the m's are the same, they have the same slope, meaning that they never touch. There are no solutions. So let's look at an example. This is from a Bell work that you had, y equals 3x plus 2, y equals 3x plus 5. So the first thing that I can see is that they have the same slope. They have the same slope. So I know that these right here, there's no solution because they're never going to touch. If I were to go ahead and graph these, this crosses at 2. Okay, it goes up 3, 1, 2, 3, goes right 1, boom. Okay, it goes like through there. Not really great on these. And then this one crosses at 5. It also goes up 3 and 1. And then not great lines, but you get the idea. They're parallel lines. They will never touch. Therefore, there are no solutions between these two lines. They will never, ever touch. They share no points. All right, the next possibility would be one solution. One solution. So what that means is that they cross in one place. So if they're not parallel and they're not the same lines, they're only going to cross one. But there is a special situation here, perpendicular, something you can just tell by looking at them. And how can you tell if they're perpendicular? You can tell if they're parallel if they have the same slope. If they're perpendicular, this is a special case of they cross once. The slopes are opposite reciprocal. Sometimes I just call that the flip opposite reciprocals, meaning they're flipped upside down. Opposite means different sign. Okay, so slopes are opposite reciprocals. And here's an example. Let's see here. 1/3. What would the flip opposite or the opposite reciprocal be? Flip it upside down, change the sign. There it is. -3/1. Okay, flipped it upside down, change the sign. So, or you could say -3/1 is the same thing as -3. So here, you try one. 2/5. Go ahead and show me the perpendicular line to that slope right there, that slope. If the slopes are opposite reciprocals, and they are perpendicular, what is the flip opposite of 2/5? Go ahead and pause it. Okay. If you said you flipped it upside down, became 5/2, okay, and then you change the sign to negative, that's what it would be. Okay. Let's look at this situation right here. Here's an example. 2/3, the flip opposite of 2/3 is -3/2. I know, since these are flip opposite, that these lines are perpendicular, meaning that they cross at right angles, and there's only one solution. I could just tell just quickly by looking. Okay? Or there could be infinite solutions. It means they're the same line. If they're the same line, they're infinite solutions. All right? If they have the same slope and the same intercept, they are the same line. So here's an example. These have the same slope, 2. Both have 2. That should have been the blue on the 2. Sorry about that. Put blue on the 2, leave the X as black. Okay, and the intercepts were 4. They both cross at 4. But what if they don't look like they have the same slope? Well, you have to have them in y equals mx plus b form. So let's look at this. Let's look at those. If x were 0, y would be 5. Same thing here. 6 times 0, 2 times what is 10? So on the blue, if x is 0, then y would still be 5 because 2 times 0 is 10. Or 2 times 5 is 10, I'm sorry. Now let's look at another number. Let's make it 1, okay? So if x is 1, what's 3 plus 5? It'd be 3 times 1, 3 plus 5 is 8. Let's look at the other one. What if 6 were 1? Okay. Well, 6 times 1 is 6. 6 plus 10 is 16. 2 times what is 16? 2 times 8 is 16. So they would share all of the same points. So you really kind of have to get them both down into y equals mx plus b form. See, you'd have to get rid of that 2. You just basically divide everything by 2. Or a quick way of looking at that, I multiplied everything here by 2 to get this. Y times 2 is 2y. 3 times 2 is 6x. 5 times 2 is 10. So that's just kind of a quick way to tell. So there's a few examples on the 3 different possibilities for the number of solutions. That would be U5. Again, if you have any questions, just let me know. Thank you very much.